Hello everyone, myself Akshita from Shri Venkateshwara College of Engineering. Today I am here to explain the topic about rank correlation. Contents: Introduction, Correlation, Regression, Carl Pearson's rank coefficient, Applications of correlation and regression, Applications of Carl Pearson's rank coefficient, Advantages and limitations, Conclusion. Introduction. In this presentation, we will explore Carl Pearson's rank correlation and its applications in correlation and regression. We will also discuss about the concept of correlation and its types and also about regression. We will understand the concept of rank correlation and how it differs from other correlation measures. We will also discuss the advantages and limitations of using rank correlation. Correlation. Definition. Correlation is a fundamental statistical concept that measures the degree and direction of a linear relationship between two variables. It allows us to understand how it changes in one variable relate to changes in another variable. Types of correlation. There are three types of correlation: positive correlation, negative correlation, no relation. What is positive correlation? When the values of the two variables move in the same directions, so that an increase or decrease in the value of one variable is followed by an increase or decrease in the value of the other variable. Negative correlation. When the values of the two variables move in the opposite direction, so that an increase or decrease in the value of one variable is followed by decrease or increase in the value of the other variable. No correlation. When there is no linear dependence or no relation between two variables, it is known as no correlation. Regression. Definition. Regression is a powerful statistical technique that is used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by y, and a series of other variables known as independent variables. Types of regression. There are several types of regression techniques, each suited for different types of data and different types of relationships. The main types of regression techniques are linear regression, polynomial regression, stepwise regression, decision tree regression, random forest regression, support vector regression, simple linear regression, multiple linear regression. Carl Pearson's rank coefficient. Definition. Carl Pearson's rank coefficient, also known as rank correlation coefficient. It is a statistical method designed to quantify the strength and direction of a relationship between two ranked variables. It offers an alternative approach when data is in the form of ranks rather than actual values. Applicability. This coefficient is particularly valuable when dealing with ordinal data, where variables have a clear order but not necessarily a precise numerical relationship. It also useful when the assumptions of linear correlation aren't met or when relationships are non-linear. Formula. The rank correlation coefficient is calculated using the formula R equal to 1 minus 6 into summation of d square divided by n into n square minus 1, where d represents the difference between the ranks of corresponding values and n is the number of pairs being analyzed. Advantages. Pearson's rank coefficient allows for the analysis of relationships that might not be accurately captured by traditional linear correlation methods. It also accommodates situations where data doesn't meet the assumptions of linear correlation. Example. Let us look into an example. Calculate the rank correlation coefficient between x and y variables. Certain x and y variables are given. Now for this we have to find the rank correlation. First let us list x, y variables separately. Then find dx minus y, that is 4 minus 6 minus 2, 8 minus 7, 1, 7 minus 8 minus 1, 6 minus 1, 5, 5 minus 5 0, 9 minus 10 minus 1, 10 minus 9 1, 3 minus 2 1, 2 minus 3 minus 1, 1 minus 4 minus 3. Now d square equal to x minus y square. Now dx minus y I have to do whole square. So 2 square 4, 1 square 1, minus 1 square 1, 5 square 25, 0 square 0, minus 1 square 1, 1 square 1, 1 square 1, minus 1 square 1, minus 3 square 9. Now summation of this d square equal to x minus y square is 44. Now let us find the rank coefficient. Formula is r equal to 1 minus 6 into summation of d square divided by n into n square minus 1. So 1 minus 6 into summation of d square is 44. So n is the total number of variables given, that they are 10. So 10 into n square minus 1 is 10 square is 100 minus 1. And next 1 minus 6 into 44 is 264 divided by 10 into 99 is 990. Now if you do subtraction of 1 minus 264 divided by 990, you will get 0.7333, which is nothing but 0.73. So the rank correlation of the given solution is 0.73. Applications of correlation and regression. Economics. Regression analysis is frequently used to predict sales based on advertising expenditures. Correlation can help understand the relationship between economic indicators such as GDP and unemployment rates. Medicine. Correlation is essential for identifying relationships between variables like dosage and drug effectiveness. Regression can aid in predicting patient based on various medical factors. Social sciences. Correlation analysis can reveal connections between variables like income and education level. Regression models can predict behaviors based on social models. Environmental studies. Researchers use correlations to understand the relationship between pollution levels and health outcomes. Regression can help estimate impact of environmental variables on ecosystems. Applications of Carl Pearson's rank coefficient. Educational research. Pearson's rank coefficient is valuable in educational studies to assess the relationship between students' rankings and their test scores. It also helps in researchers understand if higher ranked students tend to perform better. Psychology. In psychology, this coefficient aids in analyzing the correlation between rank-ordered preferences and behavior patterns. For instance, researchers can examine the relationship between rank-ordered personality traits and certain behaviors. Sports analysis. In sports, Pearson's rank coefficient can be used to evaluate the correlation between player rankings and their performance metrics. This helps teams make data-driven decisions about player selections and strategies. Advantages and limitations. Advantages of rank coefficient. Ordinal data. It's suitable for rank data where the exact numerical relationship is not known. Non-linear relationships. Works well when relationships aren't linear but still exhibit patterns. Limitations of rank coefficient. Monotonic relationships. Pearson's rank coefficient only captures monotonic relationships and may not identify other types of associations. Conclusions. In this presentation, we have learned in brief about the concepts of correlation, regression, and rank coefficient, along with their applications and significance in data analysis. Correlation helps us to understand the strength and direction of linear relationships between variables. Regression enables prediction and modeling of relationships for making informed decisions. Rank coefficient is valuable for analyzing rank data and nonlinear relationships. These statistical tools find applications in various fields from economics and medicines to psychology and sports, enhancing our understanding of complex relationships within data. Thank you.